Today on the bench I have a beautiful Longines pocket watch from 1924 in a beautifully designed full hunter case. The hallmark on the cover indicates the case material is 90% silver. As was common with Longines pocket watches of this era, it boasts the awards, or Grand Prix, won by this pioneering company at various exhibitions and fairs. Longines still exists today and is considered one of the top Swiss luxury watchmakers and has been part of the Swiss Swatch Group since 1983. The caliber of this movement is the 18.50, which measures about 40 millimeters across and contains 15 jewels between the train, balance, and pallet. According to Dr. Ramp's archives, this model of 15-jewel movement had been produced by Longines beginning as early as 1889. Longines also produced an open-face configuration known as the 18.49 as well, along with several budget-friendly versions with only 7 jewels. It runs, if you even want to call it that. The Timegrapher is a mess, and it doesn't sound great at all. One doesn't need a Timegrapher to hear all kinds of rubbing and creaks. There are two things needing to be done to release the movement from the case. First, there's a single case screw securing the movement. Second, the watch has a female stem held into the neck with a set screw that will need to be removed before the crown and stem can be pulled out. As with most pocket watches, the movement can now be removed through the front of the case. The use of dial foot screws along the edge of the movement was a common choice for this era. This may have been borrowed from the American pocket watch designs. Another option you typically see on Swiss watches is the use of eccentric screws in the main plate itself. The hour and minute wheels are now removed. With the access to the click, I can let down the remaining power of the main spring. The balance is now removed. The pallet cock and pallet fork are now removed. Some variations of the 18.50 used pallet forks with metallic pins, so this is one of the higher quality configurations produced. The escape wheel cock is now removed. Contributing to the poor performance of this movement would be the old congealed oil, which also seemed to do a great job of trapping various pieces of hair, dust, and lint over the years. The train wheel cock is removed, also revealing a similar situation on the surfaces of its jewels. Not only is that oil sticky, some of it is hardened, and it will take a great deal of effort to remove it later on. The barrel bridge is uninstalled. I like how Longines added a convenient way to let down the main spring without needing to uninstall the dial. The third wheel, fourth wheel, and escape wheel are lifted away. The stem and mainspring barrel are removed. The screw I pointed out just earlier is actually a cam that presses against the click. I'm now removing the ratchet wheel from the mainspring arbor. Okay, that's just gross. Today's special is deep fried mainspring. Ignoring that, something else doesn't quite look right. Yeah, it's all bent and kinked. But wait a minute. Check this out. Someone literally riveted a new inner coil onto the spring. Quite a crude, but if I'm being honest, skillful repair that still apparently stood the test of time. But what do you all think? Is it a hack or the work of a resourceful craftsman? Common with Swiss movements, the center wheel arbor is actually hollow, and there is an axle that runs through it on which the cannon pinion is mounted. Unlike most American movements, the MotionWorks friction is obtained between the pin and the walls of the hollow center wheel arbor, so the pin needs to be tapped out from the dial side. This is an amplitude killer right here. Notice the deep scoring on this pivot. I'll try to burnish it out as much as possible. I'm now removing the pin from the hollow center wheel arbor. Since the diameter of the pivot is 1 mm, it's too large for my benchtop jacket lathe. Fortunately, my Boley lathe came with some useful attachments, including a drum for larger sized pivots. As with the jacket tool, the wheel is placed within a female center mounted in the headstock, and a small pin protruding from that attachment leans against the arm of the wheel so that it can turn. The burnisher works the pivot that rests in the appropriately sized slot of the drum mounted in the tailstock attachment. While this is an improvement over how it was, I would have needed to do a lot more to smooth over the deeper scoring. Doing so, however, would have also removed a lot more material, and any gains I would have achieved with the smoothness would have been negated by the excessive side shake caused by the smaller size of the pivot. I'm now removing the spring that controls the return of the keyless works rocker arm. The setting lever is now removed. The keyless works rocker arm is removed with the associated crown wheel and intermediate winding and setting gears. The beefiest click spring I've ever seen is now uninstalled. Now the click is removed. I'm now removing the lower balance cap jewel plate for cleaning. As with any movement, but especially this one, The pre-cleaning ritual includes using pegwood to scrub old oil off the surfaces of the jewels. The L&R cleaner used in the machine does a fine job at cleaning the parts, but for a movement that hasn't seen a service in what seems like 50 or more years, a little manual effort is required. Sometimes I'll dip the tip of pegwood in naphtha to really get after the jewels with the most caked on oils. The rest of the movement grime is addressed with naphtha and a nylon scratch brush. This is interesting. The hairspring stud is normally held into the cock using a set screw, which appears to be missing. It would otherwise have fallen out if it weren't for all this glue, which may or may not be the work of the same, shall we say, resourceful watch servicer that riveted the mainspring together. This is no problem. I should be able to clean this up and find a suitable replacement for that missing screw. The end stone is now removed for cleaning. I typically proceed with reassembly in reverse order. The balance cock is reassembled with the cap jewel and regulator arm. As you can see, I did end up finding a replacement for that stud screw. The version 1A automatic oiler is used to deposit the precise amount of Mobius 9010 through the hole onto the end stone. Consistency is important. I want the same amount of oil on both upper and lower jewels to help reduce any positional inaccuracies. The balance wheel is reinstalled. The screw secures the hairspring stud, and then I close the regulator guard over the hairspring. The lower balance end stone setting is reinstalled. I use Mobius D5 on the higher friction surfaces, such as the post around which the click will rotate. The click spring is now reinstalled. D5 lightly lubricates the sliding surfaces of the keyless works, which is responsible for the winding and setting of the movement. The rocker arm is reinstalled over the crown wheel and intermediate gears. The setting lever is reinstalled. The mode return spring is now installed. The same amount of 90/10 is deposited onto the lower balance jewel. It's good practice to fit the balance early in assembly to check for any issues. I'm glad I did this time. Do you hear it? No, it's not Santa's sleigh. That's the sound of the hairspring making all kinds of noises. This is probably the sounds being heard at the start and why the Timegrapher reading looked like a snowstorm. Incrementally testing the subsystems allows me to find these kinds of issues earlier in isolation and helps eliminate the endless frustration of troubleshooting a fully assembled movement that's not running correctly. Suspecting the hairspring is deformed, it is first removed from the balance staff and installed by itself on the balance cock. 3 things. First, the hairspring is off-center as the collet isn't directly over the jewel. Second, the penultimate curve is leaning against the regulator pin. Finally, it's out of flat, which is probably what was causing all the noise because out of flat hairsprings can rub against the parts above and below it when it breathes. So hairspring manipulation is a challenging process that requires a lot of focus, and I was not really concerned with filming this step. Others have published great videos dedicated to this type of repair if you want to learn more. But the general approach I took is as follows. First, return the hairspring to flat. Next, work out any deformations from the innermost coils working outwards. Finally, recheck the terminal curve in various regulator positions to ensure the collet remains centered over the jewel. That looks and sounds much better. However, initially I did not notice yet another root cause of that issue that I'll also need to address. Check out that wobble. This is perplexing because the wheel itself doesn't look bent. I'll get it mounted in the truing tool for further inspection. The tool has a little arm that can be used as a visual aid to help determine how out of flat a wheel is. Notice how the gap shrinks and grows. In reality, this wheel isn't bent at all. Rather, the rivet against the staff has come loose and I'll use my staking set to shore it up. It's likely someone had replaced the staff but failed to rivet it correctly. This is a simple fix. The staff looked fine otherwise, and now with the wheel secure, I can double check its flatness. And now I'm returning the roller table to the bottom of the staff. Whenever modifying the position of anything on the balance, it's good practice to recheck its poise and make any tweaks needed to bring it back. I don't want any large oscillations like this. Basically, I want to adjust the weight so that it sort of coasts to a stop with minimal movement at the end. This helps with positional accuracy. I'm using Mobius D5 to lightly lubricate the bottom of the mainspring barrel. This movement will receive a fresh white alloy mainspring. Just a little tip, these mainspring rings have a side that is colored, which should face up when transferring the spring into the barrel. If it goes in backwards, no big deal though. You would just need to remove it and wind it back in the correct way. More D5 is applied to the spring and the hole where the arbor will turn. The mainspring barrel arbor is now installed. A touch of D5 lubricates the upper portion of the arbor before the lid is snapped onto the top of the barrel. D5 lubricates the hole in the lower plate where the mainspring barrel arbor will turn. Another higher friction surface. I'll use a little D5 where the let-down cam screw will turn. The stem is now placed onto the main plate. Beginning with the train of wheels, the escape wheel, fourth wheel, and third wheel are lowered onto the plate, ensuring their pivots find the jewel holes. The center wheel pin receives a small amount of Mobius D5 before it is inserted through the hollow arbor. I ensure there's a reasonable amount of resistance, enough friction so that the center wheel can turn the pin with the cannon pinion attached when the watch is running, but not too much where setting the time actually strains the train of wheels. The center wheel is now lowered into place. The barrel bridge is now installed. The train wheel cock is now installed. With the help of some light pressure from a peg, I manipulate the wheels until the upper pivots are seated in their respective jewel holes. The escape wheel cock is now installed. Again, light pressure and gently manipulating the wheel helps the pivot find its hole. D5 lubricates where the upper barrel arbor turns in the barrel bridge. Mobius 9010 is used to lubricate all the train wheel pivots. I'm now using Mobius 941 to oil the faces of the pallet stones. The pallet fork is now installed, with the pallet cock securing it in place. With the train of wheels and escapement fully installed, I can go ahead and apply some power to the movement. And now, the moment of truth. I'm so laser focused on seating the pivots correctly that I didn't immediately see the hairspring sitting on top of the center wheel. Much better. So right out of the gate, she's running fast, but consistent. Beat error will need to be addressed as well by adjusting the hairspring collet. That's a little better. Positionally, there's variations here, but considering the scoring on the pivots, the movement is running quite well. The cannon pinion is reinstalled with the help of the staking set so that the pin can be braced from the other side of the movement. A bit of D5 lubricates the surfaces where the hour wheel and minute wheel turn against. And now the dial washer can be placed over the hour wheel before installing the dial. The set screws along the rim of the movement plate secure the feet. The seconds hand is now installed. I was able to source a replacement set of hour and minute hands for the 18.50 online. Longines, founded in 1832 by Auguste Agassiz as Regel Jeune Annecy, produced innovative watches most notably from the late 1860s, when Agassiz brought in his nephew Ernest Francillon, who helped manage the growth. Ernest eventually assumed ownership over the company and built a factory in a location known as Les Longines, which eventually became the new name of the company. The first major innovation under his leadership was the 20A movement, featuring a pendant winding and setting mechanism, a huge improvement over the typical key wind and key set movements that were prevalent during that time. Paying close attention to the US watchmaking companies, Francillon quickly realized that the Swiss watchmaking industry needed to change to keep up with the Americans. His findings helped revolutionize the entire production process and put Longines at the forefront of the Swiss watchmaking industry. The original site of the factory he opened in 1867 still operates to this very day. This was truly a beautiful movement and my first Longines pocket watch I had the pleasure of filming. So I hope you all learned something from this video today, and if not, I hope you at least found it enjoyable. Thanks for fixing watches with me today, and I'll see you in the next one.